Today, we're taking a mind-bending journey through space with this explainer of our solar system. We're going to cross distances that totally defy human comprehension, explore planets with the most extreme environments imaginable, and dive into the deepest mysteries lurking right at the edge of the dark. Trust me, space is far stranger and way more fascinating than you probably think. So lean back and let's head into the cosmos. Section 1, 4.6 billion years ago, the birth of our sun, where a swirling cloud of gas and dust imploded under its own gravity, triggering the nuclear fusion that converted hydrogen into helium to birth our star.
Okay, let's dive into this. How exactly did all that leftover debris become the planets we know today? For a long time, astronomy was kind of messy on what actually makes a planet a planet. But in 2006, the International Astronomical Union finally laid down 3 hard rules. 1. The object has to orbit the sun. 2. It needs enough mass so its own gravity pulls it into a round shape. And 3, and this is the absolute crucial one, it must have cleared its orbital neighborhood of other debris. If a celestial body doesn't meet all 3 of those demands, well, it just doesn't make the cut.
And that strict new definition had some pretty immediate consequences. For years, we were all taught in school that there were 9 planets. But because Pluto hadn't cleared its neighborhood, it was immediately demoted to a dwarf planet, joining Ceres, Eris, Haumea, and Makemake. And just like that, it leaves us with 8 official, stately planets. Now, what's really interesting about this slide is how we can actually make these insane dimensions comprehensible. Space is, well, it's extremely spacious. To ground these massive distances in reality, let's use Rob Walrich's brilliant 1 to 100 billion scale model. If we shrink the entire solar system 100 billion times, our giant sun becomes a simple 14-millimeter marble. Our entire Earth shrinks down to an invisibly small, fine grain of sand. Even Jupiter, the absolute giant of our planets, becomes nothing more than the head of a pin. It really grounds the sheer emptiness of our solar system into objects we can literally hold in the palm of our hand. Keep that fine grain of sand in your mind for a second. On this scale, our Earth is floating about 1.5 meters away from that 14-millimeter marble sun. And that exact distance, it's absolutely crucial. We sit perfectly in the Goldilocks zone. We aren't too close, where our oceans would boil away, and we aren't too far, where everything would permanently freeze over. The temperature is simply perfect. Everything we know, our entire history, all the water, all the life, plays out on that single, perfectly positioned grain of sand. But we immediately see how fragile those perfect conditions are when we look at our nearest neighbor. Venus gets called our sister planet a lot because it's so similar to Earth in size and makeup. It's a hard, rocky world, not a star or a gas giant. But make no mistake, Venus is an absolute nightmare. While Earth is hospitable, Venus is suffering from a catastrophic runaway greenhouse effect. It's a violently hostile world where the heat is relentless and the atmospheric pressure on the surface would instantly crush you. If you've ever looked at the sky in the evening or morning and seen an incredibly bright point of light, there's a very good chance it's Venus. People mistake it for a star all the time, but it appears so incredibly bright to us because it's completely shrouded in thick, highly reflective clouds that bounce sunlight right back into space. You can't see through that cloud cover with the naked eye. It was only when scientists used radar data to peer through the clouds that they discovered a bizarre surface, covered in vast mountains, colossal volcanoes, and ancient lava flows. And our closest neighbor has some seriously mind-bending quirks. First off, a single day on Venus, the time it takes to rotate just once on its axis, is actually longer than the time it takes to complete a full orbit around the sun. A day there literally lasts longer than a year. Despite these hellish conditions, humanity has actually successfully landed spacecraft on its surface. Oh, and perhaps the most bizarre fact, even though Mercury is much closer to the sun, Venus is the hottest planet in our entire solar system, all because of that suffocating cloud cover trapping the heat. And this brilliantly illustrates how wonderful the universe truly is, especially when we compare our small planet to the vastness of the cosmos. We always think space breaks all the records, right? Well, get this. We have an estimated 3 trillion trees right here on Earth. 3 trillion. To put that in perspective, scientists estimate there are roughly 100 to 400 billion stars in the Milky Way. That means on our tiny blue grain of sand, we literally have far more trees than there are stars in our entire home galaxy. No way, right? It's completely unbelievable. Section 2, the outward journey, the gas giants. Here we transition outward to behemoths like Jupiter. A 1.3 millimeter pinhead sitting 8 meters away in our scale model whose massive gravity actually acts as our savior by deflecting Earth-bound meteoroids. Another massive difference as we head outward is the sheer number of moons. Mercury and Venus have 0. Earth has 1, but the gas giants, they have dozens upon dozens. More importantly, experts point out that icy moons like Jupiter's Europa and Saturn's Enceladus are hiding deep subglacial oceans. Because these liquid oceans rest directly on a rocky bottom and are warmed by tidal forces, they're considered the absolute dream locations in our search for extraterrestrial life. But we've got to push further out, past Saturn, past Uranus, all the way to the pale blue ice giant Neptune. Back in our scale model, this is just a coarse grain of sand, sitting a staggering 45 meters away from our marble sun. And because of that immense distance, the temperature drops to a bone-chilling minus 220 degrees Celsius. From out here, the sun is really just a bright star in a pitch-black sky. Its warmth barely reaches the planet at all. So, the crucial point is the sheer, almost incomprehensible distance involved. Neptune is roughly 4.5 billion kilometers from the sun. Time behaves totally differently out there. When the planet was discovered in 1846, we started tracking it, but it took all the way until 2011 for Neptune to complete just a single orbit around the sun since we found it. One Neptunian year takes about 165 Earth years. Section 3. The Mysterious Edge. Moving into the disk-shaped Kuiper Belt, where we explore the 2016 hypothesis by scientists Batygin and Brown that a hidden Planet 9 might be lurking, altering the orbits of nearby objects. Let's move to and see how this builds into the most mind-boggling structure of our solar system, the theoretical Oort Cloud. This is a gigantic, spherical shell enveloping our entire system. It starts at 2,000 astronomical units. That's 2,000 times the distance from the Earth to the Sun, and extends up to an astonishing 100,000 AU. It contains trillions of icy planetesimals scattered during the solar system's formation 4.6 billion years ago. This is the true deep freeze, the birthplace of ancient, long-period comets. And with that, we stand at the absolute edge of our sun's gravitational reach, staring out into the cinematic void of deep space. It begs an irresistible question. What else is hiding in the dark? Is there an alien ecosystem waiting right now beneath the ice of Enceladus? Is Planet 9 actually drifting through the shadows? And how many ancient comets are sleeping quietly in the Oort Cloud? Our exploration has really only just begun. Stay curious.